Good afternoon, dear students. Yes. So today we are going to start with a new chapter. Okay. So already we have discussed the previous chapter, metals and non-metals, right? And before that, we have discussed the chapter chemical uh, reactions and equations, right? So we have completed and already you have seen the chapter acid, bases, and salts, right? So these chapters have already completed for you. Okay, 3 chapters from chemistry have already completed. So this is the 4th chapter. Okay, that is carbon and its compounds. Okay, so let us start with the chapter carbon and its compound. So before going to the our chapter, okay, carbon and its compounds, do you know what is carbon or what are the compounds which are formed by from carbons? Yes. What is the importance of carbon in our day-to-day life? Yes. How we are going to explain that? So carbon, right? So where you will see this carbon, okay, when you see a periodic table, right? Carbon is placed in the P block, right? P block element. So we know that the periodic table is divided into 4 blocks: S block, P block, T, and F block. So this carbon is an element which is present in P block, right? So carbon, it is having a very versatile nature. Okay, so it is found in different forms, right? So when you see carbon, so carbon, okay, so it is found in different combinations, like in the presence of carbon monoxide, right? When it combines with oxygen, it forms carbon monoxide. When carbon again forms with a dioxygen, it forms carbon dioxide, right? When carbon combines with hydrogen, okay, it forms methane. So these are the different compounds from with which the carbon, when it combines with different elements, right, it forms different compound. And this carbon, okay, it is present in different, you can say in your different uh, application. Okay, carbon has different application. It is found in your day-to-day life, right? So what is the importance we are going to see in our this chapter? Okay, we are going to study about the carbon and the different important compounds and their properties. We are going to discuss, okay, and what is the importance, okay, of carbon in the elemental form. Elemental means in the form of an element as well as in the form of uh, when it combines with different elements, okay, in this combined state. So let us start. So most of the things, okay, in the nature, okay, it is made up of carbon and its compounds, right? If you have okay, so toothpaste, okay, so it contains the carbon, okay, so everything, so the important, so in the paints, okay, so everywhere you can find this carbon. Okay, so carbon has a very versatile what you can say, it has a very versatile nature. Okay, so you can, where all you can see, okay, now books, so book, okay, books, they are made up of from wood. Okay, wood is nothing but again carbon. Okay, then different, okay, in the soaps. Okay, then the pencil, the stationary item like pencil. Okay, in pencil there is a substance called as graphite. So this graphite again, it is made from carbon. Okay, it is a allotrope of carbon, right? Then different your non-living this, okay, structure, okay, your clothes, okay, then food, okay, food, then the animals, okay, they require what, they require food. Okay, how this food is produced? Okay, we take oxygen and the plants take in carbon dioxide, right? So this, okay, so this in turn will help the animals, okay, to have the food. Okay, so these are all dependable. So how this carbon is very important in our life. Okay, so all living structures and non-living structures, okay, such as the food, clothes, medicine, books. Okay, so these are all made up of carbon. Again, so when you burn this carbon, okay, for example, coal, okay, when you burn coal or when you, okay, so if any compound of carbon, when you burn, okay, what it gives, it produces carbon dioxide and water. Okay, carbon dioxide is a gas. Okay, and water. So this presence, okay, how you will understand that the carbon dioxide is liberated? Okay, so this can be confirmed. Okay, so the gas which is liberated, okay, so that is passed in a solution which is called as lime water. Okay, which is called as lime water, and which when you pass your carbon dioxide into the lime water, what it will turn, okay, lime water will be like transparent water. Okay, it will be like water. Once you pass carbon dioxide into it, it will turn like milk. Okay, it will be like white color. Okay, it will turn into milky. So this will show you that the that the carbon dioxide gas has been liberated. Okay, so whenever any carbon compound you're burning, okay, what is liberated? One is the carbon dioxide gas, another is the water. So these are the most important uh, things which is, okay, which is liberated, okay, which is produced. So again, where you can see this carbon, okay, so in the earth's crust, okay, in our earth's crust, only 0.02% of carbon is present. Okay, how it is present? In the form of minerals, okay, different in the different combination form, like in the form of carbonates, okay, carbonates, in the form of hydrogen carbonate, in the presence of petroleum, okay, petroleum, our petrol, diesel, kerosene, okay, what it consists of? All our fossil fuels, okay, it consists of, or it is made up of what? It is made up of the carbon. Okay, so in the earth's crust, it is found in the in the form of different minerals, okay, like the carbonates, hydrogen carbonates, petroleum, coal. Okay, previously in our olden days, we used to use coal, okay, for the engine. So it was a what main source, okay, to main source of energy to run the engines. Okay, so so these are the what where you can find the your carbon. Okay, so 0.02% is present in the earth's crust. Then atmosphere, okay, in the atmosphere, in the air, okay, in the air also 0.03% of carbon dioxide is present. Right, carbon, it will not be in its free state. Okay, it is formed in the form of carbon dioxide in the combination. Okay, in the combined form, you can find the carbon dioxide, okay, in atmosphere in 0.03%. So thus this carbon has very importance. Okay, it has a very important in our life. So so why carbon and why the carbon compounds are very important? Okay, so because we are using the carbon and it's which is in elemental as well as in the combined state in our day-to-day life, right? So because of this, carbon is playing a very important uh, role in our day-to-day life. Okay, so this we have seen the what carbon, okay, carbon and its importance. So next we are going to see the bonding which is present in carbon. Okay, carbon, as we have said, it is present in the p block. Carbon is having the electronic configuration of 6. Okay, so atomic number is 6. So carbon, okay, it is represented as capital C. And what is the atomic number? It is 6. And what is the atomic mass of carbon is 12. Okay, so carbon, when we write the electronic configuration means what? Distribution of electrons, okay, from lower energy to higher energy orbital, right? So so this you're in so how we are following the one rule is there, that is called as the above rule. Okay, above principle. So based on the above principle, we are filling up the electron. So the first, the electrons are filled into 1s2, okay, then 2s2 and then 2p2. So 6 electrons. So 6 electrons are accommodated. So this is the atomic number. So atomic number of carbon is what? It is 6. Okay, so what is the outermost electronic configuration. The outermost electronic configuration is 2s2 and okay, 2 and 4, right? So it is 1s2 and 2s4, right? So it is 2 and 4 is the electronic configuration, right? So the outermost electronic configuration is 4, right? The outermost electronic configuration is 4. Now we know that whenever any element is there, okay, what it will do? Either it will try to donate the electron, okay, what it will do? It will try to satisfy its valency. Okay, it will try to satisfy or it will try to attain a noble gas configuration. Okay, so what it will do, it will try to complete its noble gas configuration, means it will try to complete its octet. Okay, that is 8 electrons. So it will try to complete 8 electrons in its outermost shell. Now in our when we have written the electronic configuration of carbon, what we have seen, there are 4 electrons in the outermost shell. Okay, so it is very difficult. Okay, either the carbon has to give, okay, it has to give 4 electrons, or either it has to take 4 electrons to be in its to attain the noble gas configuration. Okay, so it is very difficult. Four electrons is a like they are very much, right, either to lose 4 electrons or to take electrons, 4 electrons. So it is very difficult for an carbon, okay, to either lose the electrons or to gain electrons. Okay, so what it will do, so because to lose the electron, okay, what would it will have, it would be difficult, okay, to hold the extra electrons. So when you want to gain the electrons, when you want to take more 4 electrons, then the energy supplied also will be more. Okay, so it will be very difficult for them to hold the electron. And when you want to lose the electrons, okay, when you want to give this 4 electron, so what will happen, the large amount of energy is required to remove this 4 electrons. So it is very difficult for the carbon atom. Why? Because to complete what any element, okay, whenever we have seen in the previous chapter about sodium. Okay, so when we write the what is the atomic number of sodium? It is 11. So when we write the electronic configuration, it is 1s2, 2s2, 2p6 and 3s1. So what sodium will try to do? How many the electrons are there in the valence shell? It has 1, right? It has 1. So uh, next to 1, there are 8 electrons, right? There are 8 electrons. So what this sodium will tend to do? It will tend to give this, okay? It will tend to lose this 1 electron, okay? It will tend to lose this 1 electron. So, why? To attain the noble gas configuration, to complete its octet, okay? Same way, but when we see of carbon, there are four electrons in the outermost shell. So because of that, okay, either to give the electrons or to take the electrons, it is very difficult. Okay, so what carbon will tend to do? Okay, what carbon will tend to do? Carbon will try to share the electrons. Okay, carbon will tend to share the electron. So how it will attain the noble gas configuration? By sharing its valence electrons. Okay, so how it can share the valence electrons? By mutually sharing. Okay, when you share them mutually, okay, so the front person has also 4 electrons and I have 4 electrons. Okay, so what I will do, I will mutually, okay, I will also give my 4 electron and the front person also will give the 4 electron. And what they will form? They will form bond. Okay, they will form mutual, they will form a new bond between these two atoms. So carbon, what it is doing, it is sharing the electron. It is sharing what? It is okay, what it will do, it will try to attain the noble gas by sharing its valence electron. Okay, so this sharing of valence electron, it is called, okay, to attain the noble gas configuration, it is called as the covalent bonding. So what is covalent bonding? Covalent bonding is nothing but it is the mutual sharing of electron takes place between the carbon and the other atom. Okay, so this is called as what? This is called as covalent bonding. So covalent bonding is nothing but mutual sharing of electron between the atoms so as it can attain the noble gas configuration. Okay, I hope this is clear. Yes, any doubts up to here? Any doubts up to here? You can ask. Okay, fine. So this was about the bonding. Okay. Now how? So now carbon. Okay, carbon, as we have discussed, carbon has how many? Carbon has 6 atomic numbers. So 1s2, 2s2, and 2p2. So there are 4 valence. Okay, 4 electrons. Okay, in its valence shell. So now carbon we are representing by C. So 4 electrons means we will write like this. Okay, each electron like this on each carbon atom. So which are the other atoms with which the carbon can share its electron? Hydrogen. Okay, hydrogen can share. Oxygen can share. Nitrogen can share. Chlorine can share. Okay, so these are the different atoms with which the carbon can share its electron. So very please note it down. What is covalent bonding? Mutual sharing of electrons between atoms to attain a stable noble gas configuration is nothing but your covalent bonding. Okay, so very important. So please mark this. Okay, what is covalent bonding? If the question is asked, you have to answer like this. Fine. So there are different types of covalent bonding. Okay, so this covalent bond which we have discussed just now, that is mutual sharing of electrons between the atoms. So this can be of 3 different types. One is the single covalent bond. Second is the double covalent bond. Third is the triple covalent bond. Okay, now what do you mean by single covalent bond? Okay, what do you mean by single covalent bond? So single covalent bond means what? Suppose I have a hydrogen. I have a hydrogen. Okay, your example is given hydrogen. So hydrogen. So what is the atomic number of hydrogen? It is 1. Okay, hydrogen is 1. So how do we represent? So how many electrons has hydrogen? Okay, hydrogen has 1 electron. Okay, so here, so hydrogen, okay, and one more hydrogen. So what, how many electrons has hydrogen? Hydrogen has 1 electron. This hydrogen, this also will have 1 electron. So what each hydrogen is doing, it is sharing the electrons. Okay, it is sharing the electrons. So this is one hydrogen, this is another hydrogen. Okay, and what these two hydrogens are doing, they are sharing the electron. So when so how this single covalent bond is formed? The single covalent bond is formed because of sharing of 2 electrons. Okay, so when 2 electrons are shared, one bond pair is formed. Okay, so this is the one bond pair. Okay, this is the one bond pair. I hope this is clear. Okay, so what is a single covalent bond? So when you share 2 electrons, okay, so single covalent bond is formed, okay, when you are sharing 2 electrons. So when 2 electrons are shared, it will form one bond pair. So what are the examples? Okay, hydrogen, chlorine, and methane. Okay, let me give you example of methane now. Carbon, okay, methane is what? CH4. So the methane is CH4. Carbon is 6, okay. When we write the electronic configuration, it is 1s2, 2s2, 2p2. Okay. So outermost valence shell electrons are how many? They are 4. So let us represent carbon. So carbon is C and 1, 2, 3, 4. Okay. 4 valence electron. Now, next is hydrogen. Is 1. Okay. So how many hydrogens were there? CH4. Right. So 1s1. So there are 4 hydrogens. So let me write 4 hydrogens here. H, 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 and H. Okay. So uh, this is carbon electrons. Okay. These are the electrons from carbon. Now let me write the each hydrogen has 1 electron. Right. Each hydrogen has 1 electron. Right. So now you see, so like this one bond pair is formed. This is another bond pair, single bond pair. This is another single bond pair, and this is another single bond pair. Okay, so methane, okay, it forms 4 single covalent bond with hydrogen atoms. Okay, it will form 4. So in Okay, so carbon, it will form four hydrogen, that is carbon and hydrogen, they are forming four single this. So what is happening? So when so single covalent bond means what? Two electrons. When two electrons are shared, it forms one single covalent bond. Okay. So here in methane, there are four four bond pairs are formed. Okay, so single covalent bonds are formed. So this was about single covalent bond, first type. Second is double covalent bond. So how this double covalent bond is formed? Double covalent bond is formed by sharing of four electrons. Okay, by sharing of four electrons. Four electrons means like this, 1, 2, 3, 4. So they will form, this will form one bond pair, another will form another bond pair. That is, it will form how many? Okay, it will form two pairs of electrons. So when two pairs of electrons is formed, two bonds are formed, two double bonds are formed. So let me take an example of oxygen molecule. Okay, oxygen molecule. So oxygen is, like atomic number is 8. So let me write the electronic configuration 1s2, 2s2 and 2p4. Okay, so what is the valence electrons? Write down the valence electron here. So oxygen, okay, oxygen is how many? How many? So 6. Okay, oxygen is having 6 valence electrons. So let me write oxygen. Here are 2. Right, 2 oxygens are there. So valence electrons. So let me write 1, 2, 3, 4. Okay, okay. Let me write off one oxygen first. So 1, 2. Okay, 3, 4, 5, and 6. Right. Same way with this 1, 2, 3, 4, 5, and 6. So here, how many pair of electrons are shared? How many pairs of electrons are shared? So this is of one oxygen. Okay. This is of another oxygen. And the sharing of electron is between these two. Okay. So this is the sharing. So this will form one bond. This will form another bond. So oxygen, double bond, oxygen. Right. So like this. So this is the your O2 molecule. So when four electrons are shared, okay, it will form a double covalent bond. Similarly, triple covalent bond means what? Triple covalent bond is formed when six pair of electrons are shared. Okay, when six electrons are shared. Six electrons. Okay, 1, 2, 3, 4, 5, 6, like this. Six electrons are shared. Okay, how many bonds it will form? Three bonds it will form. So it is called as a triple covalent bond. So triple covalent bond, how it is formed by sharing of six electron, that is three pairs of electron. Okay, so example is nitrogen molecule. Okay, nitrogen molecule. So nitrogen molecule. So it should be written as nitrogen molecule. This is hydrogen molecule. Okay, hydrogen molecule and chlorine molecule. Okay, so your so let me take nitrogen. Nitrogen, what is the atomic? This number is 7. Okay. So let me write the electronic configuration 1s2, 2s2, and 2p3, 4, 5, 6, 7. So let me write. So nitrogen molecule. Molecule is formed when two same atoms are combined. Okay. So let me take one more nitrogen. So let me write the electronics. So how many these are there? Valence electron 5. So 1, 2, okay, 3, 4, 5. Similarly, 1, 2, 3, 4, 5. Okay, so you can see. So three pairs, okay, of electrons are shared. That is six electrons are shared. So it is forming triple bond. Okay, so triple covalent bond. I hope what is covalent bonding and what are the types of covalent bonding is clear. Yes, I hope it is clear. Okay, fine. So this was about the bonding. So we have discussed what is bonding. Okay, bonding in carbon. So carbon, it is very difficult for carbon to either lose or gain the electron. So what it will do, it will participate in mutual sharing of electron, and that mutual sharing of electrons is called as a covalent bonding. So this covalent bonding is of three types. Okay, when one pair of electrons is shared, it is called a single covalent bond. When two pairs of electrons is shared, it is called as a double covalent bond. When three pairs of electrons are shared, it is called as the triple covalent bond. Okay, fine. Okay, let us go for the next one. So we have seen this, right? Electron dot structure of methane. Just now I have explained you. So carbon 6, hydrogen 1. Okay, so 1s2, 2s2, and 2p2. Okay, hydrogen is 1s1. So when we write the carbon, okay, how many electrons? 4. So carbon 1, 2, 3, 4. These are the 4 electrons. Your hydrogens, okay. How many hydrogens are there? In methane, CH4, 4. Right, so 1, 2, 3, and 4 hydrogens. So each hydrogen again, how many electrons it will give? 1 electron. So 1 electron from hydrogen, this one electron, this one, and this one. So now, okay, how it is going to form the, uh, okay, molecule. So, okay, so 1 bond, 2 bond, 3 bond, and 4. So 4 single covalent bond are formed. Okay, 4 single covalent bond are formed. 4 single covalent bond. How they are formed? By sharing 4 pairs of electrons. 4 pairs of electrons. Or you can say 8. Okay, 4 pairs of electron. Or you can say 8 electrons are shared. Okay, 8 electrons are shared. Okay, so like this, and this is called as the electron dot structure. Okay, it is called as the electron dot structure of methane. Okay, fine. Next is the allotropes of carbon. Next important thing is allotropes of carbon. What do you mean by allotrope, students? Allotrope means what? Okay, so carbon. Okay, carbon, so it is a element, okay, and this carbon, it is present in different forms, okay, in the nature it is formed in different form. So it is when it is formed, it is present in different forms, okay, it is having different physical property, okay, it is having different physical property. Now what do you mean by this allotrope? What do you mean by the word allotrope? So allotropes are, okay, so allotropes are what? They are the different forms of the same element. Okay, so allotropes means what? So carbon. Okay, so carbon, it is present in different forms. Okay, because of different physical properties. So where the atom, okay, they combine in different ways. So the way of combining it is different. So they are so that the same temperature and pressure they can exist in different form. So the way of combining, okay, it is different. It is in different way. So allotropes, they are the different forms which are present of the same element. So what are the different allotropes of carbon? So there are three important allotropes. First one is the diamond. Okay, first one is the diamond. Second is the graphite. Second is the graphite. And third one is the fullerene. Okay, third one is what? It is fullerene. Okay, so remember this. So what are allotropes? Allotropes, they are present in different forms. Okay, so carbon, as we are discussing about carbon, so carbon is present in the earth. Okay, it is present in the nature in the different forms. Okay, how it is present in different forms? Because the way of combining the carbon atoms, the way of combining the carbon atoms is in different form. Okay, because of the different physical property. Okay, so allotropes, so the three allotropes are diamond, graphite, and fullerene. So let us discuss. So you can see in the structure, okay, in your right hand side, I think you can see the picture. So this is your graphite. Okay, first one is the graphite. Then second one is the diamond. Okay, second one is the diamond. And down you can see they have given a structure. Okay, here you can see they have given the structure of diamond. So this is a graphite. Okay, this is a structure of graphite, and here this is the way of combination of the how the carbon atoms they are combining. Okay, in the form or in the diamond form, and how here the carbon have joined in the graphite, right? The structure is different in both the allotropes of carbon. Okay, diamond and graphite, you can see carbon atoms are present, but the way how they are combining it is different. Okay, so allotropes, what do you mean by allotropes? Very important. And what are the different types of allotropes of carbon? Allotropes means what? They are the different forms of the same element, okay, where the atoms will combine in different ways. Okay, so which are the allotropes of carbon? First one is the diamond, second is the graphite, and third is the fullerene. So let us see, let us discuss about the each allotrope. Okay, first one is the diamond. In diamond, you can see, so this is the diamond. Okay, first one is the diamond. Here you can see this diamond. So in this diamond, the carbon atom. Okay, so this is each, the blue color, what you can see, it is a carbon. Okay, so each here carbon atom, it is bonded to other four carbon atom. Okay, now here the blue color. Okay, the blue color dots, the blue color dot, it is a carbon. You can see if I consider this. Okay, if I consider this one carbon atom. Okay, so this carbon atom, again, it is bonded to four other carbon atom. 1, 2, okay, 3 and 4. Again, if I consider this carbon atom, okay, so carbon 1, so 2, then 3, sorry, 1, 2, 3, 4 and 5. So again, 5 carbon atoms, right? So if you consider, four carbon atoms, right? See here, this carbon atom, if I see, so this is 1, 2, 3 and 4, right? So each carbon atom, okay, it is attached to again 4 carbon atoms. If I consider this, so 1, 2, 3 and 4. So when you see the arrangement of this carbon atoms in the diamond, so each carbon atom is bonded to 4 other carbon atoms, and thus it is forming a 3-dimensional structure. So like this, okay, like this it will combine. So each carbon atom will again join the other 4 carbon atoms, and like this it is going to form what? It is going to form the structure of diamond. So like this 3-dimensional structure it is forming. Here you can see. So like this, it will form a 3-dimensional. 3-dimensional means what? From all the 3 sides, okay, it will be visible. So it is having a 3D structure. It will have a 3D structure. So you can see here. So allotrope, okay, about diamond. So in diamond, what is, you can see the arrangement, how it is. Each carbon is bonded to other 4 carbon atoms, and it will form what? It is forming a 3-dimensional structure. Okay, then next is graphite. Let us see about graphite now. In graphite, each carbon atom is bonded to 3 other carbon atoms. Okay, here it was bonded to 4 carbon atoms, but here it is bonded to how many? It is bonded to 3 other carbon atoms. Okay, it is bonded to 3 other carbon atoms. Okay. Okay, so here you can see in graphite. Okay, let us see one carbon atom. So if I consider this carbon atom, okay, I will consider this carbon atom. So let me consider this carbon atom. So this carbon atom, it is joined to 1, okay, joined to 2 and 3. Okay, same way if I consider this carbon atom, 1, 2 and 3. Okay, so like this. So this carbon atom, so 1, 2 and 3. So like this. Okay. So in graphite, so how the arrangement is different. Okay. Both the allotropes are having carbon, but the way of arrangement in diamond, each carbon atom is attached to 4 other carbon atoms. Okay. And it is forming a 3-dimensional structure. But in graphite, each carbon atom is again joined to 3 other carbon atoms. And this is forming a planar structure. Okay, like this, you can see here in the hexagonal planar structure. Here you can see the arrangement, right? So it is forming like this. Okay, it is forming a planar structure. So one, two, and again down one, three. So one, two, and three. So here you can see one, two, and three. So like this, and it is forming what? It is forming like hexagonal structure. Okay, planar hexagonal structure. It is giving you a planar hexagonal structure. Okay, like this. So graphite. Okay, so this is the way of arrangement. So one bond is double bonded. So now carbon, as you know, carbon has how many valency? Four valency. So here, what is the, so carbon, okay, what it will form? It to satisfy the valency, one of the bond will be a double bond. Okay, one of the bond will be a double bond. So it will form what? So it will satisfy the carbon valency. Please remember the arrangement. Okay, in diamond, it is each carbon atom is bonded to four other carbon atoms, and in graphite, how it is bonded? It is bonded to three other carbon atoms, and it will give you a planar. Okay, plane. It is giving, it is lying in the same plane, giving you a hexagonal array. Okay, and to satisfy the valency of the carbon, one of the bond is double bonded. Okay, and these hexagonal planes, they are one above the one below the okay, one is above, one is below, like this. One, okay, then here one, okay, above this again one. So like this, they are forming a hexagonal array. Okay, so this is 1, 2, and 3, like this. So hexagonal arrays, they are placed in layer, okay, one above the other. So this is the difference between diamond and graphite. The way of arrangement of these atoms are different. Next is the fullerene. Okay, next is the fullerene. So fullerene, okay, so fullerenes, they are the another different, what you can say, it is a different allotrope, okay, of a carbon. So it is another class. Okay, it is another class of carbon. So this was one of the fullerene. Okay, it was identified as C60. So C60 was the fullerene. Okay, in this fullerene, the carbon atoms, they are arranged in the shape of a football. You can see how the carbon atoms are arranged. They are in the shape of a football. Okay, and thus it looked like a geodesic dome. Okay, so it is looking like a dome. Okay, which was designed by the US architect Buckminster Fuller. Okay, so because of the scientist, okay, Buckminster Fuller, this C60 fullerene, okay, it was given as the name as fullerene. C16, okay, was given as the name as fullerene. Okay, so C60, so this has the how the carbon atoms are arranged. They are arranged in the shape of the football. Okay, because it is looking same as the geodesic dome. And this geodesic dome, it was designed by the US architect. His name was Buckminster Fuller. So because of the scientist, okay, this was named as a fullerene. Okay, because a geodesic dome, it was designed by the Buckminster Fuller. Okay, and from his name, the C60 carbon atom, it was named as what? Fullerene. So because of that, the third allotrope, okay, it was named as fullerene. So which are the three allotropes? So diamond, graphite, and uh, fullerene. So now when we discuss the difference, okay, between the diamond and graphite. So you can see that what did we discuss? So in diamond, okay, based on the structure, if we say the difference. So in diamond, okay, diamond, how these two structures are different. Okay, so in diamond, you can see that each carbon atom is again attached to other four carbon atoms. Okay, and because of that, it is forming a sp3 hybridization. Okay, when you have single bonds, okay, when you have a single bonds, it is called as what is the arrangement? It is sp3. In graphite, okay, the carbon atom is again attached to other three carbon atoms, and we have discussed that to satisfy the valency, one of the bond is double bond. When you have a double bond, it is called as sp2. So the graphite is sp2 hybridized. So this is the first difference. Okay, in diamond, the arrangement is sp3 hybridized, and in graphite, it is sp2 hybridized. Then when we see the this, okay, diamond is very hard, okay, it is a very hard substance, okay, and graphite, it is very smooth. Okay, you have seen the pencil lid, right? Pencil lid, it is nothing but the graphite. Okay, it is very smooth and slippery. Okay, it will break down soon, right? When you write, okay, when you write, or if the pencil fell, okay, if from your hand, the point, okay, point of that graphite, it will get cut very soon, right? So graphite, it is very smooth and it is very slippery. And when you see diamond, okay, diamond is unlike the graphite. Graphite is because it is a very good conductor of heat and electricity, but diamond is not a good conductor of heat and electricity. So these are some of the differences between the diamond and graphite. Okay, so please remember this, very important. So what are allotropes? What are the three types of allotropes, and how is the each allotrope different? Okay, how is the structure of diamond, how is the structure of graphite, and how is the structure of fullerene? Okay, so these are the three important things which you have to keep in mind. I hope this is clear. Okay, any doubts up to you, or you can ask me if you have any doubts. Okay. Fine. So let us go for the next one. So next is the versatile nature of carbon. Versatile means how? Versatile means like unique property. Okay, carbon. So it has a unique property. Versatile means it has a very unique property. So we are going to see how the why the carbon is having the versatile nature. Okay, why it is having the versatile nature. So carbon has two different property. Okay, versatile. Okay, so carbon, it is having two important property. One is catenation, another is tetravalency. One is what? One is catenation, another is tetravalency. Okay, why the carbon is having versatile nature? Because of this two unique property. First one is catenation, second is the tetravalency. So let us see what is catenation and what is tetravalency. Okay. So first one is the catenation. Catenation means what? Carbon is having the unique property, okay, to link with its, okay, self-linking property. This is called as the self-linking. So carbon can link with its similar, okay, atoms of carbon, and this is called as the self-linking. So carbon, okay, so this is called as catenation. So because of carbon, because it can link, okay, it is called as self-linking. So it can link with its atoms, okay, and it will form a bond. So this property of carbon atom to form bond with other carbon atoms is called as catenation. Very important, please note it down. What is catenation? Self-linking property of carbon is called as the catenation. So carbon can link with its atoms and form the bond, okay. So this self-linking property is called as catenation. Now how this carbon can get attached? So carbon can get attached in a single linear way, in a straight chain, okay. So when it get attached in a chain like structure, okay, in a single linear way, then it is called as the linear chain. It is called as what? It is called as a linear chain, okay. So when the carbon atoms, they are getting linked, okay, in the form of a long chains, okay. So in a straight chain, then it is called as a linear chain. Okay. Again, the carbon can get attached in the form of a branch. Okay. It can get attached in the form of a branch. Okay. So when it is forming branch like this linking, okay, when it is linking in a form of a branch, it is called as the branch chain. What it is called as? It is called as the branch chain. So carbon, when it is linking in the long form, okay, but in a straight chain, it is called as linear chaining, okay. Then second one is the branch chain. Second one is what? Branch chain. Then again, carbon can link in the form of the ring, okay. It can link in such a way that it can form ring, okay. So this is called as a ring chain. Okay, this is called as ring chain. So these are the three ways in which the carbon can get linked. Okay, self-linking. It is getting self-linking with the same with the other carbon atoms, and it is forming a bonds. Okay, so either it can link in the in the presence in the form of a straight chain. It is called as a linear chain. Either it can branch. Okay, it can form branches. It is called as a branch chain. Then carbon can link in such a way so that it can form ring. Okay, ring. So like this. This is a ring. Okay. So or else it will be like this also. So this is what it is in the form of triangle. Okay. If it is like this, then it is a square like this. Okay. So so these are the three types. Okay. Remember that linear chain, branch chain, and ring chain. Okay. I hope this is clear. Okay. So this is the first unique property of your carbon, that is catenation. Second is tetravalency. Next is what? Tetravalency. What do you mean by tetravalency? Tetravalency means because carbon is having how many electrons in its valence shell? Carbon is having 4 electrons in its valence shell. So because of that, it is capable. Okay, what carbon can do? It is capable of bonding with the other carbon atoms. Okay, other atoms like your oxygen is there, hydrogen is there, nitrogen is there, sulfur is there, chlorine is there, and some other elements are there. Okay, so because carbon, okay, it requires 4 electron. Okay, so it is called as the tetravalent. Tetra means 4. Okay, tetravalent. So because of the valency of carbon, as it is having 4, okay, it is capable of bonding, okay, with the other carbon atom. So carbon is called as tetravalency. So uh, so what it will do, it will have that property. So we have seen example of methane. So carbon, okay, it will link with the hydrogen and it will form what? Okay, because carbon is having 4 electrons. Okay, 4 electron in its valence shell. So it will share the 4 electron with the hydrogen and it will form what? It will form a bonds. Okay, it will form new bonds. So because of this is called as the tetravalency. Okay, this is called this unique property. So there are two important property. One is catenation. What is catenation and what is tetravalency? Okay, understood? What is catenation? What is tetravalency? Okay, so because of that, carbon compounds are very stable. Okay, they're very stable. Next is okay. So because of that, the carbon is said to be a versatile in nature. Okay, versatile nature of carbon is because of this two unique property. So next, okay, what are this organic compound? What do you mean by organic compound? Carbon. Okay, carbon is carbon and its compounds. Okay, okay, so they are called as what? Carbon and its compound. They are called as they are okay. So carbon and its compound. When we say carbon and its compound, they come under organic chemistry. Okay, they come under organic chemistry. So carbon, when it is obtained organic, okay, it is formed in the nature. Okay, so it was thought, okay, that organic or the carbon compounds, okay, they could only be formed with the help of a vital force. Vital force is nothing but living system. Okay, to produce the organic compound, so a living system is required. Okay, organic means what? Natural. So for production of this natural compounds, so some vital force was required. But there was a scientist called Friedrich Wöhler, okay, in the year 1828. So what he disproved, okay, he prepared urea. So urea is what? It is an organic compound, okay, and he prepared this organic compound from ammonium cyanide, okay, from ammonium cyanide. So what he did, he prepared ammonium cyanide is an inorganic compound. So what he did, he prepared the urea from ammonium cyanide. So what he did, he took ammonium cyanide and he heated it. Okay, he heated it and urea was formed. So carbon compounds, except the carbides, oxides of carbon, carbonate, and hydrogen carbonates, they are studied. Okay, they are studied. Okay, they are studying under the what? Your organic chemistry. So carbon and its compound. Okay, carbon and its compound, they come or they lie in a separate. Okay, they are studied into a separate. This that is, it is called as organic chemistry. So carbon and its compound. So how the so for preparing the organic compound, okay, or the carbon compounds, a vital force was required. So this was disproved by whom? So very important. Please remember this. There was a scientist called Friedrich Wöhler. Okay, what he did, he disapproved. Okay, by preparing the urea from ammonium cyanide. So remember that how urea was prepared. So urea was the first compound. Okay, to produce it from the ammonium cyanide. So how the urea was prepared? Urea is prepared from ammonium cyanide. Okay. So urea, so the which was the first organic compound? Urea. Okay, and how the urea organic compound was produced from ammonia cyanide, which was a inorganic. So remember that. So for production of organic compound, there is no requirement of the living system. So from inorganic system also you can prepare the organic compounds. Okay, so this was the uh, statement disproved by Friedrich Wöhler. Okay, so very important. Fine. Next is the saturated and unsaturated compounds. Okay. Now, before saturated and unsaturated. Okay. So the we are talking about carbon. Okay, carbon, and we have hydrogen. So carbon, when it combines with hydrogen, they form a compound which is called as hydrocarbon. They form a class of compound which is called as hydrocarbon. So what are hydrocarbon? Hydrocarbons are a class of compound which are made up of hydrogen and carbon. Okay, so these hydrocarbons, they are majorly, okay, divided into two types, or they are majorly classified into two types. One is the saturated, okay, one is the saturated, another is the unsaturated. Another is what? Unsaturated. Now what do you mean by saturated? Saturated means what? Between the carbon and the hydrogen, single bonds are present. Okay, between the carbon and the hydrogen, single bonds are present. Then this class of compounds, okay, are called as alkanes. They are called as what? Alkanes. So saturated compounds, okay, they are the class of hydrocarbons in which hydrogen and carbon, they are having what? Single bonds. Okay, and these are known as what? These are known as the alkenes. So what is the general formula? Very important. Please note it down. What is the general formula for alkenes? It is CnH2n plus 2. Okay, CnH2n plus 2. So please note it down. What is the general formula, okay, of alkenes is CnH2n. So this is the first classification of your hydrocarbon. Second is unsaturated compound. What do you mean by unsaturated? Unsaturated means, so the hydrocarbons in which carbon and hydrogen, okay, carbon and hydrogen, either it will have a double bond or the triple bond. So between the carbon and hydrogen, either, okay, or between the carbon-carbon bond, or between the carbon, okay, that is either a double bond is present or a triple bond is present, then they are called as unsaturated. Okay, they are called as unsaturated. Now, if you have a double bond, okay, if you have a double bond between the carbon atoms, then it is called as alkenes. What it is called as alkenes. Okay, and what is the general formula of alkene? Is CnH2n. Okay, CnH2n. So this is the general, so they are called as alkene when you have a C double bond C. So between the carbon-carbon atoms, double bonds are present, then it is called as the alkene. So they come under what? They come under the unsaturated compounds. Okay. Now, second one, the third one. Okay. So third one is what? When you have carbon-carbon triple bond. Okay. When you have a carbon-carbon triple bond, okay, then they are called as what? Alkynes. Okay, they are present, they are called as alkyne. Okay, they are called as alkyne. And what is the general formula? CnH2n minus 2. CnH2n minus 2. Please remember this. So what are hydrocarbons? So the compound which are made up of carbon and hydrogen atoms. Okay, they are called as the hydrocarbon. So these hydrocarbons are mainly classified as saturated carbon compounds and unsaturated carbon compounds. What do you mean by saturated? In saturated, between the hydrogen and carbon, single bonds are present, and this is called as alkanes. The general formula is CnH2n plus 2. Unsaturated means what? In between the carbon-carbon compounds, either double bond is present or triple bond. If double bond is present, then it is called as alkenes. If a triple bond is present, it is called as the alkynes. So alkenes, they are represented by C double bond C. The general formula is CnH2n. And between the carbon, when a triple bond is formed, that is they are called as the alkyne. That is carbon-carbon has a triple bond, and they are having the general formula as CnH2n minus 2. Okay, so this is the about your hydrocarbons and what is the saturated and unsaturated compounds. Okay, so we have discussed about the saturated and unsaturated compounds. So let me explain you again. Okay, so we have discussed about the versatile nature, okay, of carbon. So why the carbon? Because of the unique two properties, that is catenation and tetravalency. Okay. Then, so about the saturated and unsaturated carbon compounds. Okay, just now we have discussed about saturated. Saturated means what? They are linked by the single bonds between the carbon atom. So between the carbon atom, when single bond is present, then they are called as the saturated. These are not very reactive. They are not very reactive. So example given as ethane. Example is given of ethane. Okay. So ethane is a example. So carbon-carbon single bond, carbon-carbon single bond. Okay. Ethane, the formula is C2H6. C2H6. So each carbon atom. So let me write. So there are two carbon atoms, C2H6. Okay. C2H6, two carbon atom. So each carbon will have 4. Okay. Each carbon will have 4 electrons like this. Now, how many hydrogens are there in the formula? 6. So let me write 1, 2, 3, 4, 5, 6. Okay. Now each hydrogen, how many electrons it will give? 1 electron each. So 1, 2, 3, 4, 5, 6. Okay. Now let us form the bond. Okay. Like this one bond will form. Like this one bond will form. Another bond, single bond. Here one single bond. Here one single bond. And here one single bond. Okay. And here one single bond. Right. So like this, the single bonds will be formed. These are the electrons from your carbon. These are the electrons from your this carbon. Right. So how the bond is formed? So carbon, single bond carbon, here one hydrogen, here one hydrogen, here one hydrogen, here hydrogen, here one, and here one. So this is the structure of your ethane. This is the structure of your ethane. Okay. This is the structure of your ethane. Okay. So now you can see the proper. Okay. So like this, between this one bond, here 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 one bond, and here one bond. So like this, okay? So how saturated compounds are formed? By linked by single bonds, okay, between the carbon atoms, okay? Fine. So this is the electron dot structure. So what we have written, that is called as the electron dot system. We are representing the electrons of each carbon and hydrogen and how they are forming the bonds. Next, we have discussed about the unsaturated compound. Unsaturated compound means what? Between the carbon atoms, either double bond is there or triple bond is there. When you have a double bond, it is called as alkene. Okay. And when you have a triple bond, it is called as alkynes. Okay. They are called as alkynes. So this is the example of alkyne. So alkene example is ethene. Okay. Example is ethene. Ethene. Okay. So let me take a blank file. Okay. So ethene. Okay. So when you have carbon-carbon single bond, it is called as ethene. Okay. The example is given as ethene. Okay. They come under unsaturated. I am discussing about unsaturated compound. So when you have a carbon-carbon double bond, it is called as ethene. So example is C2H4. Okay. And when you have unsaturated carbon-carbon triple bond, the example is ethyne. Okay. C2H2. Ethyne. So let us write the structures. Let us write the structures of these. Okay, electron dot structure we are writing. So when we have ethene, carbon, okay, another carbon, write the electrons. So this carbon will have 4, 1, 2, 3, 4. This carbon will have 1, 2, 3, and 4. Okay, now how many hydrogens are there? How many hydrogens are there? 4 hydrogens. So let me write here 1, here 1 hydrogen. Okay, no, your little arrangement will be different. Okay, let me write here. So first we'll write the atoms. So 1, 2, 3, and 4 atoms. Now let us write the electrons for carbon. Okay, so here 1, 1. Okay, here 1, 2, and here 1, 3, 4. Then carbon, this carbon 1, 2, 3, and 4. Okay, 3 and 4. Okay, so this is hydrogen. Now each hydrogen, how many electrons? So this hydrogen 1, this hydrogen 1, this hydrogen 1, and this hydrogen 1. So this is forming one bond. 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 So I have written carbon, carbon, hydrogen, 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 hydrogen. So how many bonds are formed? So 1, 2, 3, 4. Let me write this properly. Okay, so carbon, hydrogen. Okay, hydrogen. So like this 4 bonds are formed. Now what it will form, just see. Now this one. So this will, okay, across the carbon, 8 electrons should be present. Calculate. So 1, 2, 3, 4, 5, 6, 7, 8. Yes. Now across this carbon, calculate 8 electrons. Yes, 8 electrons. So this also carbon has satisfied its octet. So how the carbon is satisfying its octet? By mutual sharing of electron, right? By mutual sharing of electrons. So what it is forming? Again, it is forming a double bond like this. So this is a ethene. I hope it is clear. Yes. So this is the ethene. So this is the electron dot structure of ethene. Clear? Clear up to here? Okay. So unsaturated compound, which is formed between two carbon atoms, when you have a double bond, it is called as unsaturated. Okay, they are termed as unsaturated, and they come under the class called as alkenes. Okay, and the example is ethene. Okay, the formula was C2H4. So just now we have shown the electron structure. Next, when you have triple bond between the two carbon atoms, they are termed as ethyne. Okay, they are termed as they are termed as alkyne. Okay, alkyne, they are termed as alkyne. Example is ethyne. Example is ethyne. Okay, so example ethyne C2H2. C2H2. So let us write carbon, carbon, okay, and hydrogen, hydrogen. Okay, now let us write the electrons of hydrogen. Hydrogens are two, each hydrogen will give one electron. The outermost electronic configuration is 1s1. Carbon will have 1s2, 2s2, and 2p2. So they are having 4 electrons. Okay, let us write 4 electrons. So 1, 2, 3, 1, 2, 3, and 4, and this one 4. Right, 4 electrons are shared. Now let us form the bond. So this will form one single bond. This will form another single bond. So if I write C, C, hydrogen, hydrogen. So these bonds are formed now. Okay. Now across this carbon atom, let us see the 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 electrons. Octet rule is octet. It has obtain its octet rule. Okay, now again across this carbon. Okay, so how many? So how many electrons are shared? 1, 2, 3. So 1, 2, 3. Right? Is it clear? Understood? Okay, so like this. So this is the what are saturated compounds? What are unsaturated compounds? Right? So and we have seen the examples of alkene, that is alkane, alkene, and alkyne. Okay, ethane, ethene, and ethyne. Is it clear? Any doubts up to here? Yes, students, any doubts? Okay, fine. Let us go for the next one. So this was about the saturated and unsaturated compounds. Next, we are going to discuss about the chain, branches, and rings. So we have seen just now that carbon atom, okay, as it can link, okay, it has a unique what property of self-linking. So it will link in the form of chains, okay, that is linear chains, or it can link in the form of branches, or it can link in the form of rings. So these are the different formula and structures of saturated compounds. Okay, saturated means what? Carbon, hydrogen, single bonds will be present. So when you have one carbon atom, they are called as methane. Okay, when carbon will combine with 4 hydrogen atom, okay, they are called as methane. How is the structure formula? Okay, like this. So just now we have seen that. So this is the structural formula of methane. When you have 2 carbon atom, okay, 2 carbon atom, okay, you have to follow this rule, CnH2n plus 2. Now put n is equals to 2, number of carbon atoms as 2. So what will be the formula? C2, okay, H 2 into 2 plus 2. So it will become 2 to the 4 and plus 6. So it will become C2H6. So when you have C2H6 formula, it is called as ethane. The name of the compound is ethane. Okay. So the formula will be how? C, C, okay, H, 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 H. Okay, like this. So this is the ethane. Okay. So please follow this formula CnH2n plus 2. Now, suppose carbon is 3. Okay, again CnH2n plus 2. Carbon is n is equals to 3. Put n is equals to 3. So C3H 2 into 3 plus 2. How much it will be? So C3H 2 3 is 6, 7, 8. So it will be C3H8, that is called as propane. Okay, when you have number of carbon atoms as 3, it is called as what? It is called as propane. Okay, the structure is like this. So the structure is like this. Then when you have number of carbon atoms as 4, okay, put n is equals to 4, it will become what? What will be the formula? It will become C4H 2 into 4 is 8 plus 2 is 10. So C4H10, it is called as butane. So this is the structure of butane. When carbon is 5, so put n is equals to 5, so it will become C5H, okay, 2 5s are 10 plus 2, 12. So C5H12, it is called as pentane. Okay, pentane means, pent means 5. So this is the structure of your pentane. When carbon is equals to 6, okay, N is equals to 6, it will become C6H14. It is 6 means hex. Okay, that is hexane. So the formula will be C6H14 and the structure is like this. Okay, so carbon when it is linked, okay, with hydrogen, okay, that is in the form of a saturated compound. That is, it is having single bonds. Okay, single bond means saturated compound. Saturated compound means the formula is CnH2n plus 2. That is, it will come under the class of alkanes. Okay, so it will follow this particular formula. So we have to substitute N depending upon the number of carbon atoms. Okay, your N can be 1, 2, 3, 4, 5. Okay, like this. So so these are the different structures. Okay. Now, so carbon skeleton of 4 carbon atoms has 2 form. So carbon, okay, if it can link, so if you have number of carbon atoms as 4, okay, I have 4 carbon atoms. So either it can link like this, okay, in a straight chain, or one possibility, again one possibility is that it can form a branching. Okay, so here uh, so carbon, so when carbon is equals to 4, right, if you have CnH2n plus 2, okay, when n is equals to 4, so that is carbon is 4, that is N is equals to 4. The formula will be C4H10. The name of the compound will be what? It is okay, butane. Okay, butane. So butane, that is it will have 4 carbon atoms. So the two different possibilities, one is in this form of straight chain, another is in the branched. Okay, another is in the form of branch. Okay. Now, if you feel the valency, now let us feel the valency. How you can feel the valency? With the help of hydrogen. Now let us write the structure. Okay, let us feel the hydrogens. So carbon has tetravalency. So 1, 2, 3 and 4. So 1, 2, again 3 and 4. 1, 2, 3 and 4. Then 1, 2, 3 and 4. So this is one compound. So this is the structure. Okay, so this is a complete molecule. Okay, so this is a butane. This is a butane. Similarly, let us write the structure for this now. So here, let us feel. So 1, 2, 3, 4. Okay, 1, 2, 3, 4. Then again here 1, 2, 3, 4. Okay, then this carbon 1. So 1 already there, 2, 3, 4. This carbon 1 already there, 2, 3, 4. Okay, so here both these structures, both the structures, above structures, they are having what formula? If you calculate, it is having C4H10, right? You can see both the given above formula. Okay, carbon skeleton, okay, with the 4 carbon atoms, they both the structures are having the same formula, that is C4H10. Okay, now these both the compounds, okay, they are having same molecular formula. The molecular formula is same, but structures are different. Okay, but different structures. What they are called as? Then they are called as structural isomers. What they are called as? Structural isomers. Okay, what do you mean by structural isomers? Same molecular formula, but the structures are different. Okay, different structures. Okay, they are called as here you can see. Okay, so this skeleton we have filled the valency, and after filling the valency, we have got this. So this is the butane. Okay, and this is isobutane. Okay, so this is the structure. Okay, so how the so when you have the same formula but different structure, then they are called as structural isomers. Okay, they are called as what? Structural isomers. Now, so here you can see the carbon has arranged in the form of a straight chain. Okay, in the form of a straight chain. Now here you can see that the carbon has arranged in the form of a branching. So beside your straight chain and branching, the carbon atoms can be arranged in the form of your ring also. In the form of the ring also. So like this, the carbon can attach. Now let us fill the valency. So 1, 2, okay, 3 and 4. So 1, 2, 3 and 4, 1, 2, 3 and 4, 1, 2, 3 and 4, right? So again the possibility of arrangement of carbon will be like this. Okay, so this is another way in which the carbon can get attached. Now put the valency. So 1, 2, 3 and 4, 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 1, 2, 3 and 4. Okay, so what we are doing, we are satisfying the tetravalency of carbon. Okay, we are satisfying the tetravalency of carbon by the hydrogen, by writing the hydrogen. So what is happening here? So the carbon, they are getting linked in the state chain, branch chain, and also in the ring. Okay, so ring. So these are the examples. So what is the name of this? 4 carbon atoms are there. Okay, so this is called as cyclobutane. This is called as what? Cyclobutane, because 4 carbon atoms, so it is butane, but it is in the form of cycle, right? Then they are called as cyclobutane. Now calculate this: 1, 2, 1, 2, 3, 4, 5, 6. 6 carbon, okay, in the form of a cyclic. So it is a cyclohexane. Okay, it is called as cyclohexane. So what is the formula here? This is C4H10 of cyclobutane, and cyclohexane is C6H12. Okay, so I hope this is clear. Okay, so the carbon can get linked in the form of chain, branches, and rings. Okay, so we have seen now. So here, okay, so cyclohexane just now I have shown, okay, in the form of rings. So they have arranged, the carbon has arranged in the skeleton, okay, 1, 2, 3, 4, 5, 6. So it is hexane, okay, hexane, and it is formed in the ring. So it is called as cyclohexane. So to satisfy the valency, okay, we have added hydrogen. So hydrogens, 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 okay, hydrogens, 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 hydrogens. So after calculate, it will become C6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So C6H12 is nothing but your cyclohexane. Okay. So carbon, it can get linked in a straight chain. It can get linked in the branches, in the form of branches, as well as in the form of rings. Okay. Fine. So if you want to write the electron dot structure, okay, if you write the electron dot structure, so this is the electron dot structure. So how it will be? It will be carbon, 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 and carbon. So each carbon will have 4 electrons. So you have to write each carbon 4 electrons like this. Okay. Then again hydrogens. Again each hydrogen. So this will give, this hydrogen here. Okay, so like this. So this is the possible electron dot structure. So it will be little tedious. Okay, so electron dot structure. So here each carbon, around the each carbon, octet rule is satisfied. So if you calculate 1, 2, 3, 4, 5, 6, 7, 8. Each carbon 1, 2, 3, 4, 5, 6, 7, 8. So mutual sharing of electron takes place and the carbon valency is satisfied and it will attain the noble gas configuration. Okay. So now what we have seen that the straight chain compounds are there, branch chain compounds are there, right? And the cyclic compounds are there. So these straight chain compounds, cyclic compounds, and the branch chain compound, they can be saturated as well as unsaturated. Okay, just now we have seen C6H12. So that was a saturated compound, that is cyclohexane. Okay, hexane. So that was a saturated compound. So it can be present in the form of unsaturated, that is C6H6. Okay, alternately double bonds when they are present. Okay, so this is your C6H6. So this is a structure. Okay, this is a structure what I have written, what is there, and I have written here. So this is the structure of benzene. Okay, this is a structure of what? Benzene. So this is benzene. Okay, and benzene was the structure given by Kekule. So Kekule was the scientist who gave the structure of benzene. So yeah, the carbon atoms, okay, when they are arranged in the straight chain, branch chain, and cyclic form, okay, they can be saturated as well as unsaturated. So the example of unsaturated, saturated we have seen cyclohexane, unsaturated is benzene. Okay, so all the carbon atoms, so just now we have seen that all the carbon atoms that contain only carbon and hydrogen, they are termed as hydrocarbons, right? Then the saturated compounds, hydrocarbons, they are called as alkanes, and unsaturated, okay, when they contain one or more double bond, they are termed as alkene. When they contain one or more triple bonds, then they are called as alkynes. Okay, remember what are hydrocarbons, what are saturated compounds. Okay, in saturated compounds, we have discussed about the alkenes. Then we have discussed about the unsaturated compounds. In unsaturated compounds, we have discussed about the alkenes and alkynes. Okay, saturated compound means carbon containing single bonds. Okay, and unsaturated means either double bond or triple bond. When you have a double bond, they are termed as alkenes. When you have a triple bond, then they are termed as alkynes. Okay, yes. Now, there are some of the functional groups which are used, okay, with this carbon compounds. So when we are having the carbon compound, now carbon, if I take a benzene, okay, if I take a benzene, so there will be, so this is a benzene. Now, there will be, suppose if I attach your halogen, okay, if I have a halogen, so which will be a halogen? So if I take a, which are the halogens? Yes, which are the halogens? Chlorine, fluorine, bromine, iodine. Okay. So if one of the hydrogen, if it is replaced by any halogen, okay, then they are termed as, or okay, so these are the some functional group which is attached. Okay. Suppose, so this is in terms of your unsaturated compound. Suppose I have CH3, CH2, Cl. So this is in terms of your saturated compound. Okay, this is a haloalkane, right? One halo group is halo. Okay, one of the halogen is combined with alkane, so it will class of compound is called as haloalkane because one of the hydrogen is substituted by your one of the hydrogen is substituted by your halogen. So which is the functional group? They are chlorine and bromine. Okay, then they are called as haloalkane. Now, suppose, okay, suppose I have CH3, CH2 and OH. Okay, so OH is the formula for alcohol. Okay, then this class of compound, they are termed as alcohol. The name of this alcohol is ethanol. Okay, it is ethanol. So like this. So the class of compounds, they are called as alcohol. Okay, suppose similarly again, so what is happening here? One of the hydrogen is been replaced by OH. Similarly, again, if I replace one of the hydrogen by aldehyde group, okay, this class of compound, they are called as aldehyde. Okay, they are called as aldehyde. So I have given you example. Okay, CHO is a aldehyde. Similarly, if one of the, okay, here it is, so what is happening? This is a ketone. Okay, ketone. So this class of compound are called as ketones. Similarly, CH3, C double bond OH. Okay, so this is a carboxylic acid. Okay, this class of compounds are called as carboxylic acid. So based on the functional group, the class of compounds will change. Okay, this is a heteroatom. So these are the different. Heteroatom means leaving your carbon and hydrogen. If other atoms are present, then they are called as a hetero. Okay, they are called as a hetero. Heteroatom means leaving your carbon and hydrogen. Okay, other atoms like oxygen, chlorine, bromine, iodine. Okay, any halogen compound is present. So then they are termed as what? Heteroatom. Okay, so this is the different. So based on the functional group, different class of compounds are formed. Okay. Next is homologous series. Next, what is the next is? Next is the homologous series. Okay. Now, what do you mean by homologous series? So it is a series of compounds in which the same functional group will be group substitutes for hydrogen in carbon chain. So It is a series of compounds in which the same functional group will substitute the what in the carbon chain. So you can see the homologous series. So we have discussed about the alkanes. We have discussed about the alkenes, right? Alcohols, carboxylic acid. So what is the general formula of alkanes? What is the general formula of alkanes? It is CnH2n plus 2, right? So you can see CH4. So these are the one, when one carbon is present, it is methane. When two carbons are present, it is ethane. When three carbons are present, it is propane. Okay, and when four carbons are present, then it is a butane. Now, between the carbon C2H6 and CH4. So what is the difference? Okay, there is a difference of one carbon and two hydrogen. Right. Again, between this C2H2 and C2H6 and C3H8. What is the difference? Again, it is a difference of CH2. Again, see the difference between C4H10 and C3H8. Again, there is a difference of CH2. So, what is a homologous series? Okay, it is the series, okay, where you can see that the compounds, okay, they are having the same functional group, okay. So, they are having the same substitution. Now, here, the difference between here, okay. So the successive members, okay, it is differing by one CH2 unit, okay, in the homologous series. So they will obey one rule, okay. So whenever so homologous series means what? They will obey one particular rule. So the difference between these series, okay, between these group, it is of CH2, okay. Now alkenes, alkenes. If you see alkenes, what is the here it is C double bond C. Now you are in alkene CnH2n. Okay, so it is having C double bond C. So ethene, ethene means again C double bond CH4. Okay, that is C2H4. Okay, C2H4, then C3H6, then C4H8. Let us see the difference between C2H4 and C3H6. So again CH2. Okay, so again here it is CH2. So again this is also differing by CH2. Okay, so same. So what is the homologous series? So it is a series of compound in which the same functional group will be substituted for hydrogen in the carbon chain. Now alcohols, okay. Now if I have a methane, okay, one of the hydrogen, what I am doing, I am substituted by OH. So this will become your methanol. Suppose I take ethane, okay. Now one of the hydrogen, it is replaced by what? It is replaced by OH. So this is called as ethanol. Right. So this is obeying the same rule. Okay. So this is called as the homologous series. Okay. So one of the, what is happening here? One of the hydrogen. In each case, what we have done, that one of the hydrogen has been replaced by your OH group. Okay. So homologous series. So series of compound in which the same functional group will be substituting for the hydrogen in the carbon chain. Okay. So here the chemical properties, okay, how they are the based on the functional group, the chemical properties will be this, okay. All the members will have similar chemical properties. Now alkane family will have similar property. Alkene family will have similar property, okay. But the physical property will be different. Chemical property will be same, but the physical property will be different. The physical property, how it will vary? It will vary depending upon the members of homologous series. That is due the difference. What was the difference between the alkane? CH2. CH2 means carbon is 12 plus hydrogen is 2. So it is 14. So the difference will arise due to the molecular mass, right? So the physical property. So the same class of homologous, okay, the members, they will have same chemical properties, but the physical properties will be different. Okay, why the difference? It is due to their molecular masses. Okay, So what will happen due to the physical properties? What are the different physical properties like your melting point, boiling point, right? So what will happen based on the molecular mass? As the molecular mass increases, the melting point and boiling point also increases. So whichever homologous series you are taking, okay, let it be alcohols, let it be alkanes, alkenes. So all these homologous series, okay, each different homologous series, they will have similar chemical properties, but the physical properties will be different because of their molecular masses. Because as the molecular masses increases, the physical property like melting point, boiling point, okay, that will get affected. So as it increases molecular mass, your boiling point and melting point also increases. So this also you have to keep in mind. So next important concept is nomenclature. What do you mean by nomenclature? Nomenclature means naming. Okay, how we can name the carbon compounds? How do we name the carbon compounds? So different names are assigned to the organic compound. Okay. So how these names are assigned to the different organic compound. So first you have to identify the okay, how to name the carbon compounds. So first you have to identify the number of carbon atoms in the compound. So first particular this. So if I have this 1, 2, and 3. Okay. So okay. So if it is, or let me write C3. Okay. So I have taken one example of C3H8. Okay. First step is identify the number of carbon atoms. So how many number of carbon atoms are there? 3. So there are 3 carbon atoms. Okay. Now functional group is indicated either by prefix or suffix. Now here, when I write this structure, okay, C, 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 then, okay, you have CH. So H, 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 and H. Okay. So this is satisfied, right? So C3H8, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now 3 carbon atoms. 3 carbon atoms means when you have number of 3 carbon atoms, it is called as pro. It is called as pro. Okay. And when you have a saturated system, okay, when you have all our carbon atoms are single bond, then they are termed as alkane. Okay, from the alkane, we are going to use the suffix as ane. What we are going to get? Ane. So the name of the compound is propane. Okay, the name of the compound is propane. Similarly, if I have C5, okay, if I have C5, H12. C5H12. So let me write 1, 2, 3, 4, 5. Okay. 1. Okay. C. Calculate. Again C5H12. Number of carbon atoms is 5. So it is pent. Okay. All the carbon atoms are having single bond. So it is alkane. And the name of the compound is pentane. Okay. Pentane. Now, suppose, okay, I have C2H4. Okay, C2H4. So CCH, H, 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 and double. Now, here, again, 2 carbon atoms means what is the name? What is the name? 2 carbon atoms means eth. Okay, and you have a double bond. Double bond means it is a unsaturated. Unsaturated means they are, when you have a double bond, it is alkene. Suffix is ene. So the name of the compound is ethene. Okay, like this. So first you have to identify the number of carbon atoms. Second is functional group. Okay, either by prefix or suffix. Prefix means the word which you add before. Okay, the word which you add before, and suffix means the word which you add after. Okay, after. Now, whenever you have a haloalkane, okay, if you have a haloalkane, the prefix which you are going to add, suppose you have a chlorine, you are going to add as chloro, bromo, etc. Okay, suppose you have a class of compound like alcohol, then the suffix, okay, the suffix which we are going to use is all. Okay. Then if you have a aldehyde, the suffix which we are going to use is al, al. If you have ketones, okay, the suffix which you are going to use is on. Okay. Then carboxylic acid, which we are going to use oic acid, OIC ACID, oic acid. If you have alkenes, we are going to write in. Okay, suffix is in. And if you have alkyne, we are going to add ine. Okay, YNE. So these are the different functional group suffixes, okay, and prefixes. So these are the suffix, okay, which we are going to use, okay. And if a suffix is added, then E is removed, okay. E is removed from the name methanol, okay. Now suppose we have CH3, okay. Now here, how methanol is obtained? So methane, okay, CH4, one of the hydrogen is replaced by your OH. So the name of the compound, one carbon, so it is meth. Okay, it is meth. Then, or you can write methane. Okay, methane. And for this, what is the alcohol, right? So we write all. So what is happening? Your E is replaced by OL. So we are going to write methanol. Okay, the name is methanol. Similarly, if you have ethane, C2H6, okay, so it will be CH3CH2. Okay, one of the hydrogen is replaced. 5 hydrogens you can see is replaced by OH. So the name will be ethane. Ethane. E will be replaced by OL. So the name will be ethanol. Okay, the name will be ethanol. So like this. Okay, like this. So like this, you are going to name the carbon compounds. I hope it is clear. Okay. So so this is the naming is very important. Okay, when you are naming the your carbon compounds. Okay. Now, next important thing is about chemical properties. Next, we are going to discuss about the chemical properties of carbon compounds. So there are 4 important chemical properties, okay, of the carbon compounds. That is combustion, okay, combustion. Next is oxidation. Then is addition reaction, and then is substitution reaction. Okay, now what do you mean by combustion? Okay. Combustion means what? Carbon compounds, okay, we generally burn, okay, how it gets generally burned, that is it gets oxidized in air, okay, and it produces carbon dioxide and water. So when your carbon compound, suppose any carbon compounds like your fossil fuels, okay, fossil fuel is nothing but suppose I use propane, because in LPG, okay, when you are using LPG, in LPG, what is present? Propane is present. Propane is nothing but your C3H8. Okay, suppose C3H8. So how this propane or your LPG will get burned? Okay, it will burn in the presence of oxygen. Okay, it will burn in the presence of oxygen. So when it burns in the presence of oxygen, okay, it produces what it will produce, it produces heat, right? It releases heat and light, and along with that heat and light, so along with heat and light, okay, when any fossil fuel burns, okay, it will oxidize means it will react with oxygen, it will give you carbon dioxide plus water. Okay, it will give you carbon dioxide plus water. So combustion is a process where your carbon compounds, okay, they generally burn. Okay, they generally burn or they get oxidized in air, and it produces carbon dioxide, water, and it releases heat and light. Okay, so propane, where it is used, it is generally used in the LPG. Okay, and LPG, why we use LPG for, it is where we use for cooking, right, in our kitchens. So it is used for cooking. So saturated hydrocarbons, they generally burn. Okay, how they burn? And they give you blue flame. So when you see the gas, okay, the LPG, when it is burning, it will give you a blue flame. Okay, and in a good supply of air. So when the supply of air is good, so it will give you a blue flame, and with a yellow sooty flame in limited supply of air. So when you have a the oxygen supply is less, when you have a very less supply of oxygen, then it will give you a yellow flame. Okay, so when the supply of oxygen is more, it will give you a blue flame. When the supply of oxygen is less, it will give you a yellow flame. So when this yellow flame, you can see when you have a unsaturated compounds. Okay, when you have unsaturated hydrocarbons. So remember that saturated hydrocarbons will give you a blue flame. Okay, it will give you a blue flame with what? Good supply of oxygen. With good supply of oxygen. Okay, and unsaturated compounds will give you a yellow flame. Okay, it will give you a yellow flame, and that is yellow flame with less or limited supply of oxygen. Limited supply of oxygen, remember this. Okay, so burning of coal and petroleum. So when you burn your petrol and your coal, so oxides of sulfur and nitrogens, okay, are given out, and these when they emit the oxides of sulfur, that is your sulfur dioxide, sulfur trioxide, or nitrogen dioxide, nitrogen nitric oxide. So when these are released into the atmosphere, so these will cause, they are responsible for the acid rain. Okay, you know what is acid rain. So because of this, whenever the coal and petroleum will okay burn, so what will happen? These acids, that is, they will emit what? They will emit your oxides of sulfur and nitrogen. So when these are left into the atmosphere, acid rain is formed. Okay. Okay. So why the acid rain is formed? Because of uh, because uh, because of the this chemical reaction. Okay, so how this acid rain is possible? Because in the atmosphere, sulfur dioxide or any nitric oxide, nitrogen dioxide is released. Okay, so they will these will get mixed up with the water. Okay, they will get mixed up in the water, oxygen in the atmosphere, and they will produce the acid rain. Okay, so this was about the combustion. Okay, combustion is nothing but burning of fuels. Okay, in the presence of what? In the presence of your uh, air. Okay, carbon compounds are nothing but your fuel. Okay, any carbon compounds, organic compounds. Okay, any fossil fuel. So when it reacts in the presence of when it is burned or it is oxidized in the presence of air. Okay, it will give you what? Carbon dioxide, water, heat, and light energy. So this is called as combustion. Okay. So remember that saturated hydrocarbons will give you blue flame. Okay. And unsaturated will give you yellow flame. In yellow flame, less amount of oxygen supply will be there. And in blue flame, more amount of oxygen supply will be there. Okay. Fine. Next is oxidation. Next is oxidation. Let us see about oxidation. Oxidation means what? Suppose I have a alcohol. Okay, I have taken here ethanol, CH3, CH2OH. Okay, alcohol in the presence of alkaline KMnO4 or oxidized. What is KMnO4, students? KMnO4 is potassium permanganate. K2Cr2O7 is potassium dichromate. So when ethanol is oxidized in the presence of alkaline KMnO4 or acidified K2Cr2O7, so these are the oxidizing agents. Okay, what it will do? Oxidizing agents, what they do? They add up oxygen. Okay, what is addition of oxygen? Addition of oxygen is called as the this oxidation. And what is oxidizing agents? Oxidizing agent, it oxidizes other and itself undergoes reduction. So alcohols, okay, what we have done, carbon compounds, okay, they will easily get oxidized in so how they will carbon compounds they easily get oxidized? Suppose if I have alcohol. So alcohol, okay, it can be converted into carboxylic acid by using any oxidizing agent. So what we are doing here, CH3, CH2OH. Okay, alcohol is converted into acid. Okay, so what is happening here? Your hydrogen, okay, your hydrogen is removed. Your hydrogen is removed, and what is added? Your hydrogen is removed and oxygen is added. Okay, hydrogen is removed and oxygen is added. So addition of oxygen. So how it is added? By adding a oxidizing agent, which is the oxidizing agent used here, KMnO4 and acid or K2Cr2O7. So oxidation is what? Oxidation means addition of oxygen. So alcohols can be easily converted into carboxylic acid by using some oxidizing agent. So which are the good oxidizing agent? One is the alkaline KMnO4, another is the acidified potassium dichromate. So what they are doing? They are adding the oxygen to the reactant. Okay. So this is oxidation. Oxidation is nothing but addition of oxygen. So this can be easily done. Next is addition reaction. Okay, addition reaction. For suppose I have ethene. Okay, I have ethene. Now this ethene, we are adding hydrogen. Okay, hydrogen is added in the presence of nickel as a catalyst. Okay, we are adding hydrogen in the presence of some catalyst. Either you can take nickel or you can take palladium. Okay, so hydrogen is added across this unsaturated carbon. What is happening? You are adding, so this bond is broken and you are adding hydrogen. So how this addition is taking place? Okay, hydrogenation. Hydrogenation is taking place. What do you mean by hydrogenation? Hydrogenation means addition of hydrogen in the presence of a catalyst. Nickel or palladium is used in the presence of, okay, nickel or palladium. We can add the hydrogen. So across the double bond, hydrogens are added. So this is about your addition reaction. So saturated fatty acids, okay, they are very harmful for health, and oils with saturated fatty acids in saturated hydrocarbon, the hydrogen attached to carbon can be replaced by another atom or group of atoms in presence of sunlight. So in most of the vegetable oils, okay, most of the vegetable oils, they are healthy. Okay, you have seen in the advertisements also. So they claim that most of the vegetable they are healthy, but animal fats, okay, generally they contain the saturated fatty acids. Okay, so because of that, these saturated fatty acids, they are very harmful. They are very harmful for the health. So oils which are containing unsaturated fatty acids should be used. So the oils which are containing oil, so whenever you are choosing any oils for the food, okay, so you have to select such oil which contains unsaturated fatty acids. So that will be essential for the cooking. Okay, so that will prevent your health. Okay, that will not give you any harmful effect for your health. So unsaturated saturated fatty acids, they are very harmful for health. So you have to choose oils with the unsaturated fatty acids. Okay, so this is about the addition reaction. So we have three chemical properties. First was the combustion, second was oxidation, third was the addition reaction. Fourth one is the substitution reaction. Okay, in substitution reaction, what happens? Okay, suppose I have methane. So methane we have taken, okay. Methane is reacted with chlorine gas. Okay, it is reacted with chlorine gas. So in the presence of chlorine gas, so what is happening? One of the hydrogen, okay, one of the hydrogen is replaced by what? It will be replaced by your Cl. So one of the hydrogen will be replaced by Cl. So saturated hydrocarbon. CH4 is what? Methane. CH4 is what? CH4 is methane. Okay. Methane, CH4. Saturated means what? Or the carbon hydrogen atoms are having single bond. So methane, okay, it is, we said what we have mentioned when we were discussing about saturated compound, they are less reactive, right? They are less reactive. Saturated compounds are saturated compounds are less reactive. Okay, so we have to consider the what methane. So in the presence of the chlorine gas, okay, what is happening now? So in the presence of the UV light, or you can say in the presence of the sunlight, okay, chlorine. Okay, so what is happening? Chlorine will be added to the hydrocarbons, and this reaction is very fast. So in the presence of the UV light, okay, or the sunlight, chlorine is added to the hydrocarbon. This reaction is very fast. So what is happening here? One of the hydrogen is getting replaced by chlorine. Okay, and slowly, what will happen? Now CH3Cl. Again, it will add chlorine, okay, in the presence of UV and sunlight. And what will happen? Again, next, this will be, next hydrogen will also be replaced. Okay, so chlorine, what it will do? Slowly, it will replace all the hydrogen atom. Okay, and so here again CH2, Cl2 plus Cl2, giving you in the presence of UV or sunlight will give you CHCl3. Okay, so again CHCl3 plus Cl2 in the presence of sunlight. So here what will happen? CCl4. So what is happening here? Okay. Okay. So what is happening in each step? Okay. So hydrogens are getting replaced, okay, by chlorine atoms. And these reactions are very fast reaction. So what is happening? Substitution is taking place. Okay. Substitution is taking place. And such reactions, they are called as a substitution reaction. Okay. So as we know, unsaturated compounds are less reactive, but that is saturated compounds are less reactive. But saturated compounds, when you react, okay, in the presence of sunlight with chlorine, what is happening? Each hydrogen is getting replaced at subsequent step. So at one step, one of the hydrogen is replaced. Second step, again next hydrogen is replaced. So subsequently, the hydrogens are getting replaced by the chlorine, and these reactions are very fast. Okay. So this is called as a substitution reaction. So substitution means what? One of the atom is replaced, or it is getting substituted by other atom. And here this reaction is very fast. So in the presence of sunlight, okay, chlorine is getting added to the hydrocarbons in very fast reaction. So these are the four important your chemical properties. Okay. So which all we have seen: combustion, oxidation, addition, and substitution reaction. I hope it is clear. Yes. Any doubts up to here? So important things we have discussed. So what all things we have discussed in from starting? Let me recap it once more. Okay, and then we will go further. So what all things we have discussed? Let me recap. Then we will go further. So startingly, we have started with the importance of carbon and its compound, right? We have started with the carbon, importance of carbon and its compound. Then we have discussed about the bonding in carbon. Okay, what is covalent bond? What are the types of covalent bond? We have discussed, okay, single covalent, double covalent, triple covalent. We have seen with the example. Then we have seen the electron dot structures also, okay, of hydrogen molecule, then of oxygen molecule, nitrogen molecule, as well as the electron dot structure of methane. Then we have discussed what are allotropes of carbon. Okay, then we have discussed the three different allotropes, how the way of arrangement of atoms, carbon atoms are different in the three cases: diamond, graphite, and fullerenes. Then we have also discussed the difference between the diamond and graphite. Okay, then how carbon is different, how it is versatile. It is having a versatile nature because of the two different properties, unique property, that is catenation and tetravalency. We have discussed what is catenation. Then we have discussed what is tetravalency, right? Then how the organic compounds are formed. So organic compound, first it was thought that only a living system was needed. But there was a scientist called Friedrich Wöhler who disproved this, okay, by preparing urea from ammonium cyanide. So this was a reaction which he gave. Then we have discussed about what are hydrocarbons, right? What are saturated compounds? What are unsaturated compounds, right? We have discussed the electron dot structure of ethane, ethene, and ethine. Then how the catenation, how the carbon will get linked in the linear chain in the form of a branch chain and ring chain. Okay, and the different formula and structures of the saturated compounds. So how the carbon with the four carbon atoms, okay, can have different forms we have seen. Okay, it can get linked in chain form, branch form, and ring form. That all things we have discussed. So saturated, unsaturated, alkynes, we have discussed. Then based upon the heteroatom, okay, which are the different class of compounds, okay, so the different functional group which we are using in the organic compounds. Then what are homologous series? Okay, what is homologous series? Which are the different homologous series we have discussed? Then we have discussed about the nomenclature of carbon compounds, right? So how we are going to name the carbon compound. So there are certain rules for naming the carbon compound. Then we have discussed the chemical properties of carbon compounds, that is combustion, oxidation, uh, addition reaction, and substitution reaction. Okay, I hope this is clear. Okay, so next we are going to discuss some of the important carbon compounds. Okay, so there are two important compounds, that is ethanol and ethanoic acid. So two important uh, this we are going to discuss carbon compound, that is ethanol and ethanoic acid. Ethanol is a alcohol, right? It is an organic compound with the molecular formula C2H5OH. Okay, C2H5OH. So ethane. So ethane is C2H6. So when one of the hydrogen is replaced by OH, okay, alcohol. So it gives you alcohol. So it is called as ethanol, or it is called as ethyl alcohol. What it is called as ethanol or ethyl alcohol. So what are the properties, and let us see the preparation of ethanol. So ethanol, how it is prepared? Okay, it is prepared so ethanol, it can be manufactured to fermentation. Okay, fermentation of molasses. The process involves very slow decomposition of a complex organic compound like molasses into simpler compounds, including ethanol, by means of microorganisms like yeast. So molasses is nothing but your waste. Okay, the waste. So from this waste, okay, what is produced? Fermentation. Fermentation means what? Microbial decomposition takes place, okay, in the presence. Okay, microbial decomposition. So because of the microbial decomposition, the fermentation takes place. Okay, so molasses means it is mostly obtained from sugarcane, the waste of sugarcane. Okay, so you can ferment the alcohol from the this, okay, the remains of the sugarcane, that is molasses. So how? By giving a slow decomposition, by microbial decomposition. Okay, so from the simpler from the complex organic compound, it is degraded into a simpler compound, and you are going to yield the alcohol. Okay, microorganisms. So what are used here? Microorganisms are used to degrade. Okay, from the complex organic compound, it is converted into simpler compound, and we are going to get the ethanol. So what are the different physical properties of ethyl alcohol? It is colorless, it is inflammable, and it is sweet smelling liquid. You are going to get a very sweet smell. It is miscible with water. Water means, miscible means it will dissolve in water. Okay, it will dissolve in water. Inflammable means it will not catch fire. Inflammable means it will not catch fire. Okay, it is a good solvent that dissolves most known substances. So it will get dissolved in most of the substances. Ethanol can cause drunkenness on consumption, even in small quantities of dilute ethanol. So if you drink this, okay, you will cause drunkenness. Okay, so even if you take it in very dilute concentration also, some dizziness will be, you will occur. Okay. So extremely poisonous when consumed in pure form. Okay. When you take the alcohol in the very pure form, it is extremely poisonous. So these are some of the physical properties of ethyl alcohol. Next are the chemical properties of ethanol. Okay. Ethanol, different chemical reactions. Why? Because of presence of the OH group. Okay, that is the hydroxy group. OH group is called as the hydroxy group. So because of the presence of this hydroxy group, there are different properties of ethanol. Firstly, when it reacts with sodium. So sodium, when it reacts with ethanol, you are going to get a sodium ethoxide. What you are going to get? Sodium ethoxide, and hydrogen gas is liberated. Okay, so this is the first reaction. So how the ethanol reacts with sodium. So ethanol reacts with sodium to give you sodium ethoxide and hydrogen gas. So this is the first reaction. So why it is giving different reaction, chemical reaction? Because of the presence of OH. Then second one is how it reacts with concentrated sulfuric acid, H2SO4. Okay, so ethanol, when it reacts with your concentrated sulfuric acid, okay, when you react it with the hot concentrated sulfuric acid, you are going to get ethene. So your concentrated acid, H2SO4, is used as a dehydrating agent. Remember that? Dehydrating agent. What do you mean by dehydrating? Dehydrating means to remove water. Okay, removal of water. Dehydration, removal of water. Okay, so your H2SO4, it is used as a dehydrating agent. It is used as what? Dehydrating agent. So what we are doing? We are heating the ethanol in the presence of hot concentrated acid at a temperature of 443 Kelvin. Okay, and it is going to give you ethene. So why concentrated H2SO4? Because it is used as a dehydrating. Dehydrating means removal of water molecule. Okay. Next is oxidation. The next reaction is oxidation. So it will undergo oxidation. Okay. How it will go undergo oxidation? So in the presence of K2Cr2O7. Okay. So when you oxidation is nothing but addition of oxygen. Okay, addition of oxygen. So when you have a alcohol initially, we are going to react with a K2Cr2O7, that is potassium dichromate. So potassium dichromate is a good oxidizing agent. So when you do oxidation of alcohol, okay, first you are going to get a aldehyde. First you are going to get a aldehyde. Again aldehyde, when you do oxidation, okay, with K2Cr2O7, we are going to get a carboxylic acid. What I'm going to get? A carboxylic acid. So what you can see here, see here, okay, one oxygen, okay. So here, one oxygen and two hydrogens are there. So here, hydrogen one is removed, right? So addition of this or removal of hydrogen, okay, removal of hydrogen is your oxidation. So here one hydrogen is removed, two are there, here one. Now here what is happening? One more oxygen is added. Okay, one more oxygen is added. So this is oxidation. Next is esterification. Esterification reactions are those where alcohol reacts with carboxylic acid to give you ester. Okay, to give you ester. So esterification reactions are formed when alcohol reacts with carboxylic acids, okay, and esters. And these esters are very sweet. You get a very sweet smell. They are they are having a very sweet smell. So esters are very sweet. They are having a very sweet smell. Because of the sweet smell, they are used in perfumes. Okay, they are used in perfumes and different flavoring agents. In the different flavoring agents, we are using the esters. So what is esterification reaction? Alcohols, when they react with carboxylic acids, you get the ester. Okay. So esters, they are very sweet smelling. Okay. So one example, ethanol is there. CH3CH2OH of esterification reacting with ethanoic acid. Okay. It is reacting with ethanoic acid. Ethanoic acid. So this is a carboxylic acid, COH, to give you what? Ethyl methyl ester. Okay. Ethyl methyl ester. So you can see CH3, C double bond O, C2H5. So this is the ester which is formed. Plus water is released. okay, along with the water. So this is esterification reaction. Very important. Mark this important esterification reaction. How the esterification reactions are formed when alcohol reacts with carboxylic acid. Okay. Esters are formed and these esters are very sweet smelling. Fine. So where these ethanol is used, okay, ethanol is used in pharmaceutical preparations like tincture of iodine, okay, tincture of iodine. If you fell down or if you get some any hurt on your external parts, so you can use a tincture of iodine, okay. So in tincture of iodine, ethanol is used, okay. Then in cough syrups, ethanol is used, and in tonics, okay, different tonics, the ethanol is used as a solvent. Then it is also used in the manufacture of organic compounds like your acetaldehyde, to preparation of your acetaldehyde in the preparation of acetic acid and chloroform. Okay, so in these preparation of the different organic compounds, ethanol is used. Then ethanol is also used as a preservative for biological specimen. Okay, for preserving any biological specimen. Okay, so that it won't get spoiled. Okay, it won't get smelled. So to in your this laboratory, biological laboratory and all. Okay, to keep the specimens, okay, for a longer period of time, ethanol is used. So these are some of the uses of ethanol. Next is the ethanoic acid. Ethanoic acid is also called as the acetic acid. So what is the formula of acetic acid? CHCCOH. Okay. So 5 to 8% solution of acetic acid in water is called as vinegar. So vinegar we use in our kitchens, right? For so yeah, vinegar is used in various this, okay. Uh, it is having a very sour taste. Okay, it is having a very sour taste. So 5% to 8% solution of acetic acid, when it is dissolved in water, you get a vinegar. So how will you prepare this ethanoic acid? Alcohol, again ethanol, when you react it with alkaline KMNO4 or acidified K2Cr247, that is when you do oxidation. Okay, when you do oxidation with this oxidizing agents like KMNO4, that is potassium permanganate or potassium dichromate, you are going to get what? You are going to get a ethanoic acid. You are going to get a carboxylic acid. Okay, you are going to get a carboxylic acid. So what are the physical properties of ethanoic acid? It is a colorless, corrosive liquid with pungent smell. Pungent means bad smell. Okay, you're going to get a very bad smell. Ethanoic acid is having a bad smell. The melting point of pure ethanoic acid is is 290 Kelvin. Okay, it is 290 Kelvin. It is 290 Kelvin. So the melting point of pure ethanoic acid is 290 Kelvin. Then ethanoic acid, it freezes during the liquid winter and is known as glacier acetic acid. So during the winters, it freezes, okay, and thus it is called as a glacier acetic acid. And this ethanoic acid, it is dissolved. It can get dissolved in water, ether, and ethyl alcohol. So it dissolves in water, ether, and ethyl alcohol. That is your ethyl alcohol. Okay. Next is the reactions. So let us see the reactions of ethanoic acid. So your ethanoic acid, when it reacts with sodium carbonate, okay, you're going to get a sodium carbonate, you're going to get a sodium acetate. Okay, I'm going to get a sodium acetate. Okay, and the byproducts are carbon dioxide and water. So this is the first reaction. So ethanoic acid, when it reacts with sodium carbonate, I'm going to get a sodium. So your H is replaced by sodium. Okay, Na plus, and you're going to get carbon dioxide, and this hydrogen will get to give you water. So sodium acetate plus carbon dioxide plus water. Second is sodium hydrogen carbonate. So when your ethanoic acid reacts with sodium hydrogen carbonate, okay, you are going to get again sodium acetate. Okay, you are going to get sodium acetate. So sodium acetate plus carbon dioxide and water. Okay, sodium acetate carbon dioxide and water. Next, when it reacts with a base, so acetic acid, right? Sodium acid, that is your acetic acid is a weak base, right? It is a weak base, weak acid, sorry. When this acid reacts with a strong base, okay, you're going to get what? Sodium acetate. What you're going to get? You're going to get a sodium acetate and water. So we know that when acid reacts with the base, you're going to get what? Salt and water. Salt and water. So what we are going to get? We are having a weak acid. Weak acid is reacting with base to give you a salt and water. Sodium acetate. Okay, we are going to get sodium acetate. So thus your acetic acid is having the acidic properties. Okay, it is showing the acidic properties. Okay, it is showing the acidic property. Next, so these were these were the about your this reaction. Let us see the uses of ethanoic acid, where we are using this ethanoic acid. It is used to preserve the food items, okay, so that it should not get spoiled. Okay, so it should not get spoiled. We are using ethanoic acid. Then manufacture of artificial fibers. Okay, for manufacturing the artificial fibers, we are using ethanoic acid. Then ethanoic acid is used for colligative latex to prepare rubber. To prepare the rubber, ethanoic acid is used. Okay, plastic rubber. Then it is used as a reagent. It is used in the reagent. Okay, in the laboratory. So in the laboratory, we use it as a reagent. Then it is used in the preparation of perfumes. So for preparing the perfume also, we are using ethanoic acid. Okay. So this was about the two compounds, that is ethanol and ethanoic acid. Okay. Next is we are going to discuss about the soaps and detergent. Okay. We are going to discuss about the soaps and detergent. Okay. So what is a soap? What is a soap? Soaps and detergent we use in our day-to-day life, right? We use in our day-to-day life. What is a soap? Soap is a sodium and potassium salt of carboxylic acid. Okay, what is a soap? Soap is a sodium and potassium salt of carboxylic acid. It is a potassium and sodium salt of carboxylic acid with a long chain. Okay, with a long chain. So they are called as the soap. Okay, it is called as the soap. And what is this soaps? They are very effective in soft water only and ineffective with hard water. Okay. Now, detergents. What do you mean by detergents? Detergents, they are made up of ammonium or sulfonate salts of carboxylic acid with long chain. So please remember, what is a soap? What is a detergent? Soap is what? It is a sodium and potassium salt of carboxylic acid with long chain. And detergents are what? Detergents are the ammonium or sulfonate salts of carboxylic acid. Okay. Soaps, they are effective only in the soft water. They are effective what? They are effective only in soft water. But your detergents, they are effective in both soft as well as hard water. Your soap is ineffective with the hard water, but your detergents, they are effective in both soft as well as hard water. So now, whenever we are considering the soap molecule, in soap molecule, there is two parts. One is the hydrophilic part, another is the hydrophobic part. What do you mean by hydrophilic? Hydrophilic means water loving. Okay, it is the water loving. So hydrophilic is the ionic part. It is the ionic part and it is a long hydrocarbon chain. Okay, and hydrophobic means water hating. Okay, hydrophobic means water hating. So a soap consists of two parts. Okay, one is the ionic part, another is the hydrophobic part, hydrophilic and hydrophobic part. So long chain of carboxylic acid, okay, hydrophobic ionic end and hydrophilic ionic end. So these are the, whenever you are considering the soap, okay, so these are the two ends. So the ionic end of the soap, what it will do? It will interact with the water. Okay, while the carbon, carbon chain, okay, the carbon chain will interact with the oil. Okay, And these soap molecules, what they will do? They will form the micelles. Okay, they will form the micelles. Where one end, okay, one end of the molecule, it will be towards the oil droplet, while the ionic end, it will be facing the outside. Okay, so this is about the, so let us see about the, so this was about the soaps and the detergent. So what is soap and what is detergent? Very important. So in soap, there are two parts. One is the ionic part, another is the hydrophobic part. Okay, ionic means water loving, hydrophobic means water heating. Okay, now let us see the cleansing action. Okay, let us see the cleansing action. So how the soap, okay, how when we use soap, how it will clean. Okay, so most dirt is the oily in nature. Like the dirt which will be there on our clothes, it will be mostly what? It will be oily in nature. So, and the hydrophobic ends, what it will do, it will attach itself with the dirt. So whenever the hydrophobic, so we have discussed that in a soap, one will be the hydrophilic and another will be the hydrophobic. So hydrophobic, what will happen? It will get attached to the dirt. While the ionic end, what it will do, it will surround with the molecules of water. So molecules of water will be present. So what will happen? Because of that, there will be micelle formation. Okay, there will be micelle formation. So an emulsion is thus formed by soap molecules. So this is produced, right? White color foamy, this will be produced. It is due to what? It is due to the soap molecule. So because in soap, two ends are there. So whatever the hydrophobic is there, it will get attached to the oil or the dirt, and the hydrophilic, that is which is ionic part, it will get attached to the water. Okay, it will be surrounded by the water. Now there is something. So an emulsion is thus formed by the soap molecule. The cloth needs to be mechanically agitated. So because of that, the what foam is produced. Then what we do? Then we hit the clothes, right? The we do it mechanically, okay, so that the dirt particles will be removed from the clothes. So this is the cleansing action of the soap. So remember that to a soap, two ends are there. One will be the hydrophobic end, another will be the hydrophilic. Hydrophobic will get attached to the dirt, and hydrophilic will be surrounded by the water molecules. Okay. Then after that, this emulsion is produced by the soap molecule, and what will happen? The cloth is agitated so that it will remove the dirt particles from the cloth. Okay. Next is scum. There is something called as scum. What do you mean by scum? The magnesium and calcium salts present in hard water, they react with the soap molecules. Okay. They react with the soap molecules so that they form insoluble products called as scum, thus obstructing the cleansing action. So sometimes the clothes don't get cleaned properly. Why? Because when we use hard water, in hard water, what is present? Calcium and the magnesium salts are present. These calcium and magnesium salts, okay, when we use the hard water, they react with the soap molecule and they produce the insoluble product that is called as scum. And because of that, what will happen? The clothes won't get cleaned properly. Okay, because hard water, if we use hard water, because in hard water, what is present? Calcium and magnesium salt, and they produce insoluble product that is scum. So because of that, the clothes won't be clean. So use of detergents overcome this problem, as the detergent molecule prevents the formation of insoluble product. So that time, okay. So if there is a hard water, so what we are going to do? We are going to use the detergents. Why? Because detergents, what they will do? They will prevent the formation of the insoluble product. And thus, what will happen? They won't form scum and the clothes get clean. So we know that soaps, okay, when we are using soaps are only good in soft water. Okay. But when we are using detergents are good both in the soft water as well as in the hard water. Okay. So this is the cleansing action of soap. I hope this is clear. Okay. So this was about the cleansing action of soap and detergents. Okay. So I hope this is clear. So this completes your chapter carbon and its compounds. Okay. So these were the things which has to be discussed in the this particular chapter. So most of the things, yeah, everything we have discussed. Okay. So okay. So previously we have recapped. Okay, we have recapped everything. What all we have discussed. Okay. So then also we have discussed about the two important compounds, that is ethanol and ethanoic acid. Okay, we have discussed their properties. Okay, what are the properties of each? Then physical properties, the preparations. Okay, reactions, chemical reactions, and uses. Right. Then we have discussed about the soaps and detergents and the cleansing action. I hope it is clear. Right. So most of the things we have discussed. I hope everything is clear. Okay, fine. So let me end this session here. Okay. So this completes your chapter, carbon and its compound. I hope there are no doubts. Okay. So I'll end this session here. Okay. So we'll meet in the next class. Thank you.